Hello everyone, once again I'm back. My name is Manuel Chunga, and then today I'll be dealing with mathematics N5. So basically today I want to do the application of differentiation. You remember when you're doing mathematics N5, you start with the limits and then you do differentiation and then you do the application of differentiation, which is your question 3 and also chapter 3 on your textbook. So simply on application of differentiation, that's whereby you're drawing the graph, and then when you're drawing the graph, you know the first thing you have to find the roots of those graphs, and then sometimes on the initial roots of finding the graph, we use what we call the quadratic equation, the one that you know from grade 12, which says x is equals to minus b plus or minus the root of b squared minus 4ac divided by 2a. So to find the roots, there are different methods that we can use to find our roots. We can either use the table method, or we can use the graph method, or we can use what we call the Newton's method, or sometimes they call it the Tyler method. And then on the Tyler method, there's a formula that you use, or the Newton method. It says for you to find the root, it says x2 is equal to x1 minus f at x divided by the f at f derivation. So which means you are going to have your function to get your f at x prime. You are going to derive your function that which will be given. So without wasting much of your time, I would like to do from the question memo. We are going to do from the past question paper. And the one that I want to do is July 2018. July 2018. Question 3. So let me just write. It says f at x is equals to 7x to the power 3 and 3 minus 8x plus 4. So you are given a certain function which says 7x cubed minus 8x plus 4. So your first question, I'm going to post the question so you can see it on 3.1. They're saying determine the coordinate of the point of inflection of f at x 3 marks. So they want me to determine the coordinates. And how am I going to determine the coordinates of these? So this is how you determine your coordinates. You're going to derive your function and then equate it to 0. So let me derive this. This is my f at x prime is equals to, let me just have my calculator with me. Let's derive this. Will be 7 by 3. I get 21 x squared, okay, minus x. And you know whenever you're deriving a constant is what? It's 0 when you're doing your chapter 2. Okay, so now I have a function which says 21x squared minus 8. So for me to use the quadratic equation, I have to have the value of a, b, and 1 and c. So here I only have 2 values, which means I cannot use the quadratic formula. So I'm going to derive again my formula, which is going to be, I dropped down this 21 times 2, which is 42x, and then when you derive your 8, it's going to be 0. And I said you are going to equate this to 0, the same as 42. X is equals to 0, and then you find your value of what? Of x. I divide by 42. This one cancels this one, and now I'm gonna have x is equals to what? X is equals to 0. So now I have the value of what? Of x. And remember, when you're drawing your graph, you need the value of x. You also need the value of what? Of y. So how am I going to get my value of y? I'm going to substitute my value of x in the original equation. So wherever I see my x, I'm going to substitute the value that I have here. So this is same as 0 is equals to, sorry, let me just substitute here. So it's going to be 7, okay, 0 to the power 3 minus, and then okay, 0 plus 4, and then I get my value of what? I get my value of y. So this is 7, I substitute 0, okay, to the power 3, to the power 3 minus 8, and then 0, okay, plus 4, which I get the value of what? Of 4. So I know I have my turning point, which is what? Which is 0 and what? And 4, which is the other one is value of x, the other one is value of what? Of y, which means this is my 3.1.1. Alright, okay. So on 3.1.2, they're saying draw up a table of x and f at x, where x is ranging from x is equals to -2 to x is equals to what? To 2. So on this one, on 3.1.2, they want you to draw a table whereby they give you the range. So what you're going to do, you're just going to draw your table. You draw your table. So you say x, or sometimes here you can say f at x, or you can say y, is still fine. And then this is negative. I'm given the range from -2, -1, 0, 1, and 2. So this is the range that you are given. So guys, in order for you to get this point, I'm just going to use my calculator to get those values, to get my table. So I'm just going to punch on my calculator the whole equation, or the original equation. So on your calculator, you just press mod, and then you say number 3, which is the table, and then it gives you f at x. When it says f at x, you're just going to punch the whole equation, which is 7, and then x cubed minus 8 x, okay, plus 4. Okay, so it says gx, and then you say equals, and then so when it says start, you just want to say it starts from -2 equals, and then it end is going to end at 2, and then step, it means the step. So I'm going to use a step of 1, and I said equals, and then your calculator is going to give you the value of x and also the value of f at x. Okay, so when x is equals to -2, it's -36, and then when x is -1, here it's 5. When x is 0, here it's 4, and then when it's 1, here it's 3, and then when it's 2, it's what? It's 44. So this is how you get your table. So for the table, you don't have to strike it, you can just punch the table. Okay, so I said in order for you to punch the table, you're just gonna say a table, and then you put your equation on your calculator. You're given the range, you just punch the range from -2 to 2, and then step you use 1 equals, you get your table, you just draw it like that. So it's very simple to do that. And then on 3.1.3, they're saying draw a neat graph of f at x between those values showing the turning points. So now they want you to draw the graph. So mostly guys, they will ask you to calculate the coordinates of the point. They will say draw the table, and then you draw the graph, and then you show or you indicate the turning point. So let me do that. I'm just gonna do a rough sketch over here. Okay, so I have -2. Let me just see how can I draw this. So my graph is gonna be, let me see here. Let's say -2 is somewhere here. I have -2 and 36 somewhere here, and then I have -1, -1 and 5, which is somewhere here, and then I have something like this, and then I have, which is 1. I'm just gonna do a rough sketch, and then I can have 1 and 3, which is somewhere here, and then 2. So I have a graph which is something like this. Okay, my graph is not that unique. Remember, I'm just drawing on the board. So when you're drawing on the board, you just plot the correct one, and then remember you have your turning point, which is what? Which is 0 and what? And 4, and this is your equation, which says plus, so f at x is equals to Is equals to this. So after you're done, this is your graph. You just show. They said you must show the turning point. There is my turning point, and so it means I show my turning point, and then you are done with that. And then on 3.1.4, I don't know which part should I rub. Which part should I rub? Okay, let me just rub this side. This side. Okay, so on 3.1.4, they're saying one of the root of the equation f at x is close to 7 cubed minus 8x plus 8 is close to -1. These values and one of the approximate of Taylor method to determine the better approximation of the root corrected to 3 decimal figures. So now they want me to calculate the approximate of the roots using what? Using the Taylor Newton method, and I say your formula that you are going to use, it says x2 is equals to x1 minus f at x divided by f at x prime or derivation. Alright, okay, and then they gave me my value of x, which is they're saying it's close to negative 1. So what are you going to do? You are going to substitute your value. Okay, let us see. So this is close to x minus x1 minus my f at x, which is 7x cubed minus 8x plus 4, divided by my derivation, which is this, which is 21x squared minus 8, and then you just substitute the value that you are given, which is close to -1. So it is equals to -1 minus 7, -1 to the power 3 minus 8, -1 plus 4 divided by 21, -1 squared minus 8, and then you get your value. Let us see. Okay, so this is -1 minus. Okay, let us see. This is 7 minus 1 cubed minus 8 minus 1, okay, plus 4 divided by 21 open bracket minus 1 squared minus 8. Okay, so I'm going to get my range as -1,385, and remember they said up to 3 decimal places. In other cases they can ask you to zoom in, and then you just use this one, you substitute as your value of x1. Now you just repeat the same thing, but on this one, this is your answer. So basically that's it about your 3.1. So first, let's say they will ask you to calculate what the turning points. After turning point, they will ask you about the table, and then I said the table you can just use your calculator, and after you have to draw your graph showing the turning point, and then after they will ask you to calculate the approximate roots using the Newton method, which is what I did on this side. So simply that's it about this question of 3.1 of July 2018. So we can also try to do a different one.